Okay, so I'll be doing this video in different parts so that it won't be too lengthy and bulky. So this first part will just be basically opening the software, selecting the workbench system, what to use, then creating the geometry. So the first thing to do is for ANSYS, you can go to the Start menu, then go to ANSYS, depending on the version, but you should see it here. So you click the drop down arrow and scroll down. You should see workbench. So you click this workbench. For me, I've already put it in my taskbar. So once you click workbench, something like this will open. But normally when you click the workbench, it will keep on asking you some prompts to keep on appearing. You keep on accepting them, clicking yes until it opens like this. So once this opens, for this particular project, it's a fluid flow project. So, and they also said that we should use ANSYS Fluent. So by the left here, you'll see fluid flow fluent. So you simply click it. You can either double click it or you can click and drag. So you drag it into this green box. You can see as I drag it into the green box, this turns red. Once it turns red, I can leave it. Then over a few seconds, this will open up. So you should have something like this. Then the first thing you want to do is you can model it on SolidWorks, any software, save it as a step file and open it here. But sometimes, especially when you have to transfer the ANSYS files from one computer to another, you can have complexities. So I'm trying to avoid that. And we're going to be using a 2D system. I'll explain that. So because of all those factors, it's just better to use ANSYS modeling softwares to create your geometry. So first thing we'll do is, normally when you're doing fluid flow for pipes, in fact fluid flow generally, if you have a somewhat symmetrical system, instead of doing a 3D model, you can just do a 2D model. The results you get are going to be exactly the same. It's just a way of simplifying the system so that you don't spend so much time analyzing the results. The simulation time will also drop and all of that. So because for this particular work we're going to use a 2D system, you would have to right click on geometry, then select properties. So this would appear. Then when you scroll down, that you see analysis type is normally set on 3D. You change it to 2D. So that's the first thing you do. Then you come back to geometry and right click. Now there are two tools you can use to do your geometry: Design Modeler and Space Claim. Design Modeler is the older one, but it's more complicated to work with. Space Claim is more modern. So you click New Space Claim Geometry. It's going to take quite some time to open normally, so you just wait for it. I'll fast forward this so that you don't have to wait. So whatever appears, you keep on clicking allow access. I think several of it will appear. Alright, so as we can see, Space Claim has opened. Now one thing you must try to avoid whenever you're designing on Space Claim, especially if you want to use the model for the simulation, make sure you don't save the model. Never press Ctrl S or click save. it would complicate you, start having issues transferring it to the next stage of the simulation. So make sure you don't click save. So once this opens, the first thing you want to do is to select a plane where you draw, and normally for this work it will be better to work with the XY plane so that it will face you. So if you should come here, you see select new sketch plane, you click it, then you move your mouse until, see, as you move it towards in between this X and Y, a plane will appear between X and Y, then you click it. So once you've clicked it, I think this should be normal too, yes, plan view, so it will face you. So what we want to design, we want it to be symmetrical, so we can just design and mirror it. So we can use this construction line, you click it and just draw it. So move your mouse horizontal, don't click. As you move it, what I'm drawing is going to be about 800 millimeters. So you can just use any length. It's a construction line, the length doesn't really matter, but let me just use 800. So you can see it will zoom out like that. So the next thing I want to do, what I'm actually trying to draw is a cross section of a pipe. So, and this particular project, they said it's a converging pipe, they didn't give dimensions, so I'm choosing my own dimensions. I want the dimension at the inlet to be 100 mm, then the dimension at the outlet to be 30 mm. So since I'm doing a mirrored kind of thing, I can use 50 mm here. So I'll click on this the normal line tool here, then move it to this point, click, move it up, make sure it's vertical, then I'll type 50 and press enter. Then okay, let me press escape. I'll use this my construction line, come to the end here, click, move it up. Then since I want this end to be 30, I'll use half of it, that's 15. So I'll type 15, press enter. Then I'll go back to the normal line that I have, then move it here, click, then move it to this 30 and click. Then I would also want, okay, let me leave that first. So escape, press escape. So what you want to do now is to mirror what you've drawn. So the mirror tool should be, okay, let me just confirm. It's been a while I use the software. Well, there's a mirror tool, but interestingly I can't find it, so I guess I'll just have to construct this the normal way, the longer way. So I would also go back to construction line, click here, take it down, press 15, then I'll come to this side, also take it down, press 50. Then from here I would click this point, take it here and click. So I will now need to delete these construction lines at the edge here. Click this one, delete it, come to this side just so that it doesn't interfere. This one I would also delete it because I want one straight line down. So I'll click the normal line tool, join these two places, come to this end, click and join this. So we have, this is the geometry that we want. This is what's it called? the length of this is 800, the inlet is 100, the outlet is 30. So if you would want to, because okay, sure, that will be my own part, no need for that. So once you're done with this, if you move here, you see return to 3D mode. So once you click that, you see it has changed this to a surface. So once you've done this, because we're using a 2D analysis, which is a cross section of the pipe, and basically this inner, what we just constructed is the cross section of the inner part of the pipe, which is where the fluid is contained. So you're only concerned with the fluid, you're not concerned with, especially for this analysis, we're not including temperature, all those things. It's just to check the flow. So once you're done with this, don't click anything, just close space clean. Don't press Ctrl S, nothing, just close it. So if you notice now, you see that the geometry has a tick. So at this point, though you can do it earlier, but we're meant to actually save this document, so you can press Ctrl S. I already have a folder for ANSYS, so you can call this fluid flow. Sorry, it's good you create a new folder for this particular project, because ANSYS, when you create one file, when you save one file, it will create multiple files, so that this place doesn't get messed up. You can create a new folder, create fluid flow, then open that folder and save the file inside the folder. Alright, so we've done this and we are set to move to model. So I'll stop this video so that then we'll proceed with the next one.